welcome back, and as always, thanks for tuning back in. So I've got a couple of boxes here sent courtesy from AKK, and you'll find their shop on Amazon. They reached out to me via the channel and asked if I'd review a couple of their products. So I picked a couple of simple things and thought I would just go through and do a typical unboxing. We'll do a weigh-in, but then we'll do some power checks on the transmitter, and we're going to do some RF checks. Some just general RF checks on the equipment, just to see how nicely this plays with 433, if any of you guys are running a UHF system. So, first off, we can get started with the transmitter. Pretty standard fare here with the 40 channel transmitters, but one of the nice things that I'm starting to see a lot of manufacturers do is start to incorporate these pigtails. Part of the issue is that when you get into crashes, and you're going to crash, it's just a fact of life. The hardwired, or the hard mounts, the SMA edge mounts that are on a lot of these transmitters can literally rip the board right in half. Whereas with these RG316 cables, it adds just a little bit of strain relief, to a fairly delicate component. One of the other nice things about this is the size here. We're looking at about so 20 millimeters wide by, by 28 millimeters tall. So it's pretty tiny. The only other transmitters that I've seen this small are like the AOM way transmitters and a few other variants, like the TS variants. In terms of connectors, you have these JST GH locking connectors. This is a nice addition. They're a little bit easier to work with than the JST Pico Blade type connectors, but that you have to mash in. The other nice thing here is that it's a one-button operation, so long press, short press, really long press is all you really need to do to get to the power outputs, the channel assignments, as well as the actual channels. And it does cover all of the standard channels. So yeah, one of the nice things that I'm starting to see, especially in packages this small, is you're getting 3 power outputs, so 25 milliwatt, 200 milliwatt, and 600 milliwatt. And so yeah, if you were to compare this against, say, what I feel is kind of the gold standard in this space, which is the Ridimate RC Cricket Pro, which is also a switchable output transmitter. I mean, look at the size comparison there, and the weight comparison also. I'm sure you'd be able to save a few grams there. But this is like a $60 transmitter. This is a $25 transmitter. Granted, this is a $60, $50-$60 transmitter backed by what I feel is one of the best companies in the FPV space. So, what's up there, Alex? Anyway, so yeah, again, a lot of really great things here. Now, one small omission from this that I have seen with a lot of other transmitters is a dedicated 5-volt out. I don't see. Yeah, no, there's no 5-volt output for this. So, a typical setup is you would use one power output to come into here, and then use the regulator on here to feed 5-volt out to your camera. So you're going to have to figure out a powering scheme for your camera. I wouldn't call that an oversight. I mean, it's really tough to cram that much technology onto one little board like this. So just one of those things to consider. So yeah, I mean, as far as the wiring's concerned, you've got this really nice silicon stranded 30 gauge wiring. This is something that I'm seeing on a lot of equipment these days. They finally switched away from that UL 1007 wire to this 30 gauge flexible silicon wire. So that's really nice. And obviously, don't bury this TX. You need to make sure that you have access to this button. Once you get the initial settings in, you get your channel, you get your band, and then you get your channel. Every time you turn this on, it will power up. It will remember those and power up, and start transmitting right away. So it's not like some of the other transmitters where you have to press a button to transmit. You only have to do that the first time, and after you do that the first time, every time you power it up, it'll remember that band and that channel, and it'll start transmitting right away. Okay, so let's do a quick weigh-in. Okay, weight-wise, let's see what we're looking at here. Comes in at about 10.5 grams, not bad. And then, of course, with the wiring. So yeah, about 13 grams. That's pretty good for a micro build. Alright, so what I've got here is I've got the transmitter hooked up to my immersion RC power meter. We're going to do a quick power check in all the different modes, but we're also going to look at the different button presses that it takes to move through the menu system. It's a very simple, very intuitive system, I think. One long press gets you between the band and the channel. You just look for whichever character is flashing. So one long press gets you into the band channel, another long press gets you into the channel, and then once you're in this mode, you can just wait for it to stop blinking and then be able to flip through. And then if you do one really long press, so get into flashing mode and then just keep holding it, and then you'll see this dash here. One dash means 25 milliwatts, 2 means 200 milliwatts, and 3 means 600 milliwatts. Now if you look at the power meter here, so 0 means it's on but not transmitting. So if you ever needed to do, I don't know, a channel change or something without transmitting, if you didn't have an antenna on or something, that's that mode. And let's see. So hold. And so that's 25 milliwatts, and this is popping out about 50 milliwatts there. That's 200 milliwatts. We're already up around 475. Now these numbers will fluctuate. This is not an exact science with this, but and for full power, you're looking at about 740, 750 milliwatts. So the power outputs check out, though that middle one is a little suspect. One of the big issues here with these high power transmitters is that they have a tendency to shoot off a lot of near field interference. And by near field interference, this is not going to be a huge issue for you if you're running like your standard 2.4, 5.8 gigahertz setups on like racing quadcopters. But if you want to use something like this for 433, or if you wanted to use this with a UHF control system, it's very important to know what the near field noise looks like. Otherwise, you'll run into a situation where your transmitter or any of the other systems in the area can end up swamping out your control signal. So we're going to check that out right now. And this is an RF Explorer. This is this is the 3G model. So this is the one that scans from between from between 15 megahertz and 2700 megahertz. But we're using the 433 scan here. So and what this is a near field sensor. This is almost like it provides a pinpoint precision so that you can go down to like component level measurements instead of just kind of like far field or near field measurements where they might not necessarily be as precise. So just give me a second to get this set up. So when you're using your RF Explorer for these types of tests, and I'm just going to do something a little wonky here so I can get everything on camera. What you're trying to do is you want to check to see the You want to check the transmission lines, and you want to check the component itself to see if there's excessive emissions. And if you can look at one of my older videos to see what excessive emissions look like. So this is on in low power mode, so 25 milliwatts, and I'm going through all the wiring and just double checking to see if I see anything. But you don't start to see anything until you are about this far away from the components. So typically that's going to be the processor that's going to fire off all of that interference, and you're looking at about minus 90 dB on this scale. So if we pop this up to, we increase the power now. Oops. So if we increase the power to 2, so now we're at 200 milliwatts. And then we do that scan again. Starting to get a little bit more on the emission side, and it takes a couple seconds for the averages to register. So okay, we're settling in around the minus 90 dB. Okay, so it's fluctuating, but you're starting to get into the the critical space here. What you're looking for is around the 433 range, anything in the 80 to 70 dB range. And mind you, that's if your UHF antenna was this far away from the transmitter, it would be seeing this kind of noise. So let's see what full power looks like, because this is where usually you'll see the most. This is usually where you'll see the most noise. So give that a second. Goes through and starts sampling. So this is with the near field sensor, literally a couple millimeters off of the deck there. But this is where you'll start to see a little bit more noise. And just if you watch the sensor here, a little far away, close, a little far away. So if you're going to be using this in a UHF application, just make sure that you you follow your rules and make sure that you're doing good, that you've got good separation from between the components. But from a component test, this is actually coming in pretty good for noise. I've seen some transmitters, like especially the TS line transmitters, the near field sensor could be over here, and it could just be spiking, and they're just not useful for UHF applications. So pretty good job there. So yeah, that does it for this transmitter. Again, this comes in two variants, both about $26, $25. There's one with the pigtail, and then there's one with the hard mount SMA. But I'm a big fan of the pigtails if you have the space for it. If you don't, then obviously you'll have to go for the hard mount version, and then just make sure that you keep this this button accessible. So pretty good job with that. Now what we're going to do is I'm going to hook up the camera to this, and we're going to try to get some sample footage and see what the camera looks like. Alright, and as far as the camera's concerned, that's the model number, the AKK CA20. This is a 600 TVL camera. That's the Sony SuperHAD 2 CCD, so it's a 1/3 inch sensor. Standard HS1177 footprint rather, and this comes with a 2.8 millimeter lens. So you're looking at about a field of view of about 110, 115, 120 degrees. These are, this is fine for general applications, but it tends to be a little bit on the small side, or the narrow side rather, for things like multi-rotor racing. So multi-rotor racing, you want to be somewhere in the 2.1, 2.5 range. 2.5 is kind of the sweet spot, at least as far as the stuff that I fly for, in close flying. If you're up in a plane, this is going to be fine, but for multi-rotor racing, you might want to consider swapping that out with like a 2.5 lens. But yeah, as far as componentry is concerned, it did take a peek inside, and it does have the just to quickly verify that it does have the DSP, that next chip 2040 DSP. It's the same processing chip in a lot of the other HS1177 and HS1177 variants. One of the great things about that is it's one of the best sensors out there for wide dynamic range applications. Things where you're going to be flying at dusk, and you've got a dark ground versus a very highly lit sky. So great cameras for that kind of application. Now these do come in a couple of different orientations, where the connector's on top and where the connector's on bottom. So you're going to need to make sure that you just verify that. And as far as the cables are concerned, nothing too crazy here. Again, pretty standard fare. You've got your OSD cable, and that's not OSD like Foxy or OSD, where you can measure voltage and time aloft. This is just to do the picture settings online, and I'll walk you through what that looks like in just a sec. And then as far as the other connectors are concerned, nothing too crazy. You've got your standard 1.25 millimeter connectors here. So these are the JST Pico Blade connectors. Oops, that's upside down. It's a 4-pin connector, so it's in your voltage in, ground, video, and then OSD. Now in terms of input voltage, you are looking at a 5 to 22 volt input range, so that gives you a lot of flexibility with a lot of different setups. Alright, so I've got this powered up, and it's actually transmitting through the AKK transmitter. And let's go ahead and zoom in on the screen. Now mind you, the white balance is a little bit off here. These are not the real colors. They're actually a little more saturated on my side. But I just wanted to just do a couple of quick kind of unscientific tests here, just to see how this is set up. Now, out of the box, this is already pretty decently focused. Yeah, my focusing chart's not flat, but right off the bat, usually if it's not in focus, you can't even see that center spiral. So that's pretty good there. Now, in terms of settings, let's take a look at the settings. That's something that always kind of stymies people. I've got the OSD set up on here, so whenever I'm setting up a camera, I set them all up pretty much the same way. So lens is going to be Manual exposure. You can set a shutter. You can set it to auto. If if you're in lighting conditions that aren't changing a lot, just leave it to auto and then kind of be done with it. But if you're going to be if you're going to be flying in a challenging lighting scenario, you can set the shutter so it stays where it is, and then just kind of let the camera fight through whatever it needs to. Automatic gain control is typically something I turn off, but dynamic wide range is something that I do turn on. Brightness, this is typically your preference, but I leave this kind of like around the 50 range. You don't want to make this overly bright. And then, so pull that back. White balance, you can play with this. There's usually like a regular white balance and then one that's, sorry, let me get, there's usually the standard white balance, which is a little bit cooler, and then a little bit warmer, second default, or you can just do your own. It's up to you. That's pretty much a preference thing. And as far as the backlight is concerned, you can leave that off. Day and night, you always want this to be set to color. Otherwise, if you are flying in low lighting conditions, this can switch between color and black and white, and that can sometimes screw you up. So I leave mine in color. DPC we're not going to touch. Special. So cam title, pretty standard stuff here. You can drop in the name of your rig. But for image adjust, this is where we start to play with some of the different options. So 2 times dynamic range, so leave that on. Mirror is off. Font color, you can leave that where it is. Contrast, usually the default's fine for that. Sharpness, you've got a little bit of latitude here to bump that up. But the display, we change this to, sorry, let me come back. So for display, I'm moving right here, and I go to user, and then so you get some options here to increase the brightness or decrease the brightness and contrast. Color gain this is one of those things that a lot of people kind of play around with. The defaults at 175 tend to be a little bit washed out. I find that my preference tends to be like around 205, 210. Some people go as high as like 230, which is just a little bit too much, like when I'm reviewing the footage. So try to keep it sane kind of around that level. And then if you're finding that it's just not bright enough, you can bring down that gamma level right there. So those are two of the most important settings that you can get right when it comes to let's see here, return, when it comes to setting up your camera. And after that, that's pretty much it. Those are the changes that I use to ensure that wide dynamic range is on, backlights are off, that your shutter speed is auto, and that some of your color gain and color settings are nice and set up. So let's see, cam title. Some people like to play with the park line. They get those they get those parking lines in the screen. That's always something fun to work with, but I'm not going to do that here. So let's see. And that should do it. So yeah, and that's the AK C20. Let me just press stop there. One last final thing we wanted to do was just double check what the RFE is coming back with. So getting a couple of spurs. So one spur there on 429. That would be something to keep an eye out on. But that's literally right on the backboard. All of these these are typically harmonics that get generated off of the CPU, but they're not. The near field sensor is so close to this that I imagine that if you had a UHF antenna, you'd have to be somewhere within 10 inches to pick up something like that. So I wouldn't worry too much about what you're seeing here, but that's always just useful to know that there are spurs on the 443 and 430 430 range. So yeah, that about wraps it up for these guys. And again, thanks to AKK for sending these out for review. These are pretty interesting. I've amassed a ton of gear. Some of it's good, some of it's really not good. This looks on the surface to be pretty decent, quality-wise, and it seems to be a pretty good value. pricing wise, you're looking at for similar equivalents from RunCam, $25 versus $35. 25 versus $60 in some cases, but we'll see. I'll see if I can get these slapped onto a rig and take these out for some flights and see what see how they perform. But other than that, thanks for tuning in.